Good day, everyone. So our topic for today is all about determinants. So before we tackle about the definition of properties, let's have first what is determinants. So in a linear algebra, we can compute the determinants of square matrices. A square matrix is a matrix that has equal number of rows and columns. For example, a square of matrix of 2 by 2 order has 2 rows and 2 columns. Similarly, the square matrix of 3 by 3 order has 3 rows and 3 columns. Similarly, we have higher order matrices such as 4 by 4, 5 by 5, and so on. Determinants can be employed to analyze or find solutions of linear equations. So besides linear algebra, the determinants have many applications in the fields such as engineering, economics, science, and social science. The determinant of the matrix B is denoted as absolute value of B or det B. It is easy to calculate the determinant of a 2 by 2 matrix. So for example, consider this following square matrix. So the determinant of the above matrix will be denoted as absolute value of B. It is calculated by multiplying the diagonals and placing a negative sign between them. The determinant of 3 by 3 and 4 by 4 matrices are computed using different and somewhat complex procedures than this one. You can also use matrix calculator to calculate the determinants of higher order derivatives. Determinants have some properties that are useful as they permit us to generate the sum results with different and simpler configurations of entries or elements. So, there are 10 main properties of determinants, which includes reflection property, all-zero property, proportionality or repetition property, switching property, scalar multiple property, sum property, invariance property, factor property, triangle property, and lastly the cofactor matrix property. So now let's explore first the reflection property. If the rows of the matrix are converted into columns and columns into rows, then the determinant remain unchanged. This property is known as reflection property of determinants. We can also say that the determinant of the matrix and its transpose are equal. So to find the transpose of a matrix, we change the rows into columns and columns into rows. The second one is the all-zero property. If every element in a row or column is 0, then the determinant of the matrix is 0. The third one is the proportionality or repetition property. If all the elements of a row or column in a matrix are identical or proportional to the elements of some other row or column, then the determinant of the matrix is 0. For example, consider the following matrix in which the second row is proportional to the first row. So since the elements in the second row are obtained by multiplying the elements in the first row by the number 3, therefore the determinant of the matrix is 0.
So let's move on for the fourth property, which is the switching property. If the position of any two rows or columns is interchanged, then the determinant of the matrix changes its sign. It means that if it was positive before interchanging, then it will become negative after the change of position, and vice versa. For example, consider the following matrix. So the determinant of this matrix is the absolute value of A is equals to 18 minus 15 is equals to 3. Now let us see what happens in the rows or columns are interchanged. So we have interchanged the position of rows. So the determinant of this matrix will be The absolute of A is equals to 15 minus 18 equals negative 3. Fifth property is a triangle property. So if each element in the matrix above or below the main diagonal is 0, the determinant is equal to the product of the elements in the diagonal. For example, consider the following matrix. The determinant of the matrix will be the absolute value of A is equals to 5 times 3 times 2 is equals to 30. So sixth property is the scalar multiple property. If we multiply all the elements of a row or column in the matrix by some non-zero constant, then the determinant of such matrix will be multiplied by the same constant. For example, consider the following matrix. So its determinant is the absolute value of A is equals to 8 minus 2 equals 6. Let us multiply all the elements in the above matrix by 2. A is equals to 4 times 2, 2 times 4. So the absolute value of A is equals to 16 minus 4 equals 12. You can see in the above example that after multiplying one row by number 2, the determinant of the new matrix was also multiplied by the same number 2. Seventh property is the sum property. So as you observe, just simply add the A and the B. So A plus B is equals to this. This would be the result. So let's cite for another example. So example, apply the properties of the determinants and calculate. In this example, we are given two matrices. We need to find the determinants of these matrices. So let us start with the matrix A. The absolute value of A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see that in the above matrix, the rows and columns are proportional to each other. In other words, we can say that when we add 3 to each element in the row 1, we can get row 2. Similarly, when we add 3 to each element in the row 2, we get the row 3. So proportionality or repetition property says that the determinant of the matrix is 0. Hence, we can say that the absolute value of A is equal to 0. Now let us proceed to the matrix B. In the matrix B, all elements above and below the main diagonal are zeros. According to the triangular property, the determinant of such matrix is equal to the product of elements in the diagonal. Hence, the determinant of matrix B is the absolute value of B is equals to 1 times 1 times 1 is equals to 1.
The next property of the determinant is a factor property. If a determinant triangle becomes 0, while considering the value of x equals a, then x minus a is considered as a factor of triangle. The next property is a triangle property. If each element in the matrix above or below the mean diagonal is 0, the determinant is equal to the product of the element in the diagonal. Like for example, of this matrix. So, we just need to multiply the diagonal like 5, 3, and 2. So, the product of this diagonal is 30. 5 times 3 times 2 is equals to 30. So, and last property of the determinant is cofactor matrix property. A cofactors refers to the number you attain on removing the column and row of a particular element existing in a matrix. So, that's all the property of the determinant. Thank you.